Hello everyone, welcome back. I am Mr. Dean Cobalt, and today we are going to be talking about significant figures once again, but this time we are going to be talking about them in the context of multiplying and dividing. In the last video, I talked about significant figures with regard to adding and subtracting. There was the rule. The rule was that your answer after you add and subtract should have the same number of decimal places as the least number decimal places in the quantities that you were adding and subtracting. The rule for multiplying and dividing is similar, so don't confuse this rule with the one for adding and subtracting. Students often get this confused, so try not to do that yourselves. So for significant figures in multiplying and dividing, when I'm trying to figure out how many of the digits I should keep on my calculator, I need to go by the least number of significant figures. So instead of decimal places, I'm looking at significant figures. That's the big difference in the rule. So, so I have three examples again. So I'm going to go over the three examples and show you how this rule applies to multiplying and dividing. So again, you can plug this into your calculator and it'll spit the answer out for you. So you don't need to know, really, this is not testing again your ability to add and multiply and divide. It's whether or not you know how many digits to keep in your answer on your calculator. So let the calculator do its work, and then you have to figure out how many digits to keep. So you punch these numbers into your calculator, you're multiplying this many inches with this many inches with this many inches, and you get this on your calculator. It's a volume inches cubed. And so now you have to figure out how many digits to keep. Well, just like we looked at decimal places, we're looking at the least number, the same number of significant figures as the fewest in your multiplying, in your factors. So this one has, remember your Sigfig rules, the 0 is significant and the rest of it is significant. So this is going to be 4 sigfigs. Again, the 0 is significant because it lies between the two non-zero numbers. The rest are non-zeros. So this is going to be 5 significant figures. And then this 0 here is a leading 0. It's at the front. So those are never significant. So you're going to ignore that one, and then so you just have these two. So you have 2 significant figures. The least number of significant figures in this example is 2. So you're only allowed to keep 2 significant figures. So you keep the 6 and the 7. There's your 2, and you cut it off there. So again, rounding, this is a 2, so you keep the 7. So your answer that you report is going to be 6.7 inches cubed. So that would be your final answer. Okay, what about example number 2? Same thing. Now we are dividing, so the same rule applies to both multiplication and division. So I divide these numbers together. I get this on my calculator. And so how many digits am I allowed to keep? So we're going to look at the sig figs again. So again, these 2 zeros are going to be significant because they lie between 2 non-zero numbers. So all of these digits are significant. So this is going to have 5 significant figures. And then this 0 is significant. It is a trailing 0, and the rule was if you have a decimal point and you have a trailing 0, then the 0 is significant. So that 0 is significant, so this one is going to have 3 sig figs. So 3 is the lesser one than 5, so I can only keep 3. So again, that 0 doesn't count. It's not a significant 0. So I'm going to keep 1, 2, and 3. So I cut it off here. And so since that's a 0, I keep the 6 a 6. And so I would report this as my answer. Okay. Now, the last problem here, it's a mixture of multiplication and division. So, again, I punch these into my calculator and I get this answer on my calculator. So how many am I allowed to keep? Once again, we look at the number of sig figs. This 0 is a trailing 0. It's at the very end of your number after the last non-zero digit. So there is a decimal, so that 0 is significant. So this one has 3 significant figures. This 0 is a leading 0. It's at the very front of the number. Those are never significant. But it does have a 0 at the end of the number, and there is a decimal point. So that 0 is significant. So this is going to have 4 significant figures. Here we have 2 zeros in the middle. So they're sandwiched by 2 non-zero numbers, so those are significant. So this one is going to have 5 significant figures. And finally, we have no zeros here, so this is easy. All of those digits are significant, so we have 5 there too. So 3, 4, 5, 5. The least number is 3, so our answer can only have 3 sig figs. So again, this 0 is not significant. So there's 1 significant, 2, and 3, so we cut it off at the 2. And I would report 1.652 inches cubed. So that would be the answer I would report. And so that's how you apply the rule of multiplying and dividing to figure out how many digits you're allowed to keep. Next video, what happens when I mix up the operations? What happens if I have multiplying and dividing and adding and subtracting all in one problem? Or maybe in steps of the same problem to get to my final answer? How do I figure out the number of digits I keep in my final answer? And that's in the next video. So stay tuned. Thanks for watching, and I'll see you guys next time.